All right. So today we're going to cover arrays. All right. Arrays are very helpful from a programmer's perspective. Can anybody tell me what an array is or what it's like? Anybody? Well, arrays are like lists, right? They hold essentially a list of data. And the key kind of benefit of arrays are that in memory, each spot in our array is stored sequentially in memory. So memory creates a block and stores your array there. Whereas when we create other variables, and let's say we have A1, that's our array, A1. A1 is all of this information here, starting here down to here. So this is index 0, 1, 2, 3, 4. Right, we have our array, again, it's sequentially in memory. When we have other variables, let's say we have an integer num. Num may point there. We create num2. Num2 points here. Right, num3 points here. Num4 may be up here. You never know where your data is. That's what I'm trying to get at. You never know exactly where it's stored. Now you can get the address. Actually, I believe in Java you cannot. In C++, you can get the actual address. All right, but in Java you cannot. And so arrays, on the other hand, store it sequentially in memory. So we can go 0, 1, 2, 3. We can go all the way down the list, if you will, in an array. Okay. So to that point, arrays are like lists again. All right. And like a list, you can select different indices inside array. So we start here. We have our array. We have our size. The first index in an array is 0. We always start at 0. The next index is 1 all the way down. All right. So this is our array, right? We have a list of numbers, or we can have a list of strings, whatever it may be. You can have a list of many different things. In this class, we'll have lists of objects, okay? And so you can store all of those inside an array. The benefit is previously we'd have to create a variable for each one of these indices. Now all we have to do is create one array, add our data to that array. All right, we don't have to create all these many different variables and try to keep track of them. Plus, depending on what the user inputs, we may have 100 variables we want to keep track of, or maybe 2. For you to have to sit there and create 100 individual variables would be unrealistic, right? And a complete waste of time, especially when we have this data structure, an array, at our disposal. Okay. So again, an array is like a list. We can store data in this list. Again, the data can be a number, integer, double, or a string, any of those. In the future, we'll store objects in an array. And of course, we'll go into objects later on. So question for the audience, what is the size of my array? What is the length? How many indices do I have?
11.
11, correct. The length of this array equals 11. All right. And again, we can store data in that array. How we initialize an array or declare it actually, similar to how we declare other variables. Say, for example, we want to create an integer, int number That's how we declare it. And then we could do things like number equals 7, number plus equal 8 equals 15, plus equal 8. And then this would compute to 15, right? So now number would equal 15. Okay. We can do double num2 equals double number divided by 2. And that's not how it would look in Java. So let me write it like it would look in Java. Equals double number divided by 2. What would be the outcome of that equation? Come on, don't be shy. I know it's somewhat early.
Would it be 7.5?
Correct. Num2 would equal 7.5. What if I do this? Is my outcome still 7.5? Yes or no? Thumbs up or thumbs down? Something.
Yeah.
Yes.
So in this scenario, it's funny. It's actually 7. All right. Because if you remember, since number right here is an integer, if you divide an integer, you're going to chop off the decimal point. Right. What I did previously when I had I thought I could undo. There we go. When I had this, come on. When I had that full statement, I'm converting number into a double, and then I'm dividing by 2. Right. This is called explicit casting. Right? You're converting it to a double, then you're dividing it by 2. That way we retain that decimal point. Okay. Any questions about that? All right. Well, if you notice here and here, we declare 2 different variables. One is an integer and one is a double. Okay. So if we want to declare an array, very similar. Let's say we want an array of size 5 that holds integers. We would go int, brace, whatever we want to name it. So let's name it scores equals new int. And then once we have this brace, we put our size in here, 5. And so this would be an array that holds 5 integers. If we want to create a string array, we could do string, brace, names equals new string, 15. This array would hold 15 strings. And again, a string is not just a word or a character. A string can be a whole sentence, a paragraph. Strings can be fairly large. What if I do this? What is the length of this array? How many indices does it have? Come on, I
Would it
don't like
be
the monologue. What was
would
that?
it be with the user inputs?
What is the current value of number?
Just the word number?
Yeah, that's the variable name. What is the current value? What is what? How
7.
you said 7?
Yeah.
So starting up here, 7, right? But what do we do here? What do we do there?
7.5.
Not quite. This statement right
7
here.
plus 8.
Go ahead.
7 plus 8.
Correct. Correct. Which is 15. So now the size of our array down here is 15. All right. So whatever the current value of number is what the size of our array is. The reason I showed you that example is because whatever your size is does not have to be explicit. You don't have to exactly know what it is as long as Java knows it. So for example, if the user types in the value of number, as the programmer, before we create our array, we may not know the size. However, Java would, right? We have a variable that keeps track of that size, and we could put that in as our array length. Okay. Is that clear, or should I go through that again?
Could you go through that again just so I can be clear on it?
Yeah. So let's do this. So let's say I have some numbers, right? Int size equals 0. Okay. I do this for int equals int I equals 0. I is less than 75. I plus plus. Okay. Inside here, I do size plus plus. Okay. Size minus equal 15. I'm sorry. Minus equal 25. Size equals size divided by 2. Int scores. Let's make this array. Int scores equals new int size. All right. So in programming, we're going to do a lot of these different things, right? So if you imagine all these programs we use throughout our daily lives, there are some complex logical expressions in those programs. You just got to imagine there are. And so doing something like this is not out of the question. You may have a size, you add to it, you subtract from it, you divide it, you multiply it to get your final number. And that's how many indices you want in your array. All right. Anybody tell me what the size of the length of our array is? Can anybody tell me? Okay.
12.5.
It's actually really close. Really close.
12.
So this
You said int can't have a 0.5 or something like that.
correct. You can't have a 0.5 for the length of your array.
It's only real numbers.
Correct.
Okay.
So after we do the for loop here, What is the value of size?
Right where it says equals 25.
Nope, that's a minus equal. So we're actually subtracting from size. After we do this for loop though, what is size equal?
Zero.
Not quite. We are
Um,
modifying the value of size right here. So we are doing something to it. What are we doing right here? What do these plus plus do? Anything plus plus adds 1 to that variable.
So it's 2.
Not quite. So we're adding 1 here,
Uh,
right? But how many times are we going through this for loop? How many times do we loop through this for loop? 75 times. Right? We're looping through 75 times and adding 1 to size each time we go through this loop. So the first time we go through, size equals 1. The next time we go through, size equals 2, then 3, 4, 5, 6, 7. So what will be the final value of size once this for loop goes all the way through?
75.
75, correct. All right. So now we're on this statement. Size minus equal 25. What does size equal?
50.
50. In this statement, size equals size divided by 2. What does size equal?
25.
Yep. So what is the length of our scores array?
25.
25. Correct. Again, as a programmer, we know 75, right? We can see 75 up here. So we know score is going to start off after we go through the for loop at 75. We subtract 25 from that, and we divide it by 2. So we could figure this out. However, the more complex our programs get, the harder it will be for us to figure out the size. But we know that Java knows the size, right? And our array has a set size. Once you create it, that is the length of your array. So once I create this scores array, it will hold exactly 25 scores, no more or no less. Did that make more sense?
Mm-hmm.
Mm-hmm.
Yes, sir.
All right, so let's go into the code. Let's actually make a running program because I think it's great to talk about it theoretically, but I want to show you as well. All right. All right. So again, we want to start our program. So again, to create a project, we click on this little, I think it's like an orange little box with a green add button. Again, you can do your programs right now. This is the last week using the Java Visualizer. However, starting next week, all of your assignments and your labs will be done using NetBeans. Also, starting Monday, we will be back in the classroom. All right, Yancey 117, starting Monday. Okay. And again, for those of you whose face I cannot see, you will get booted from class. All right, review 4.
Let me stop playing with this shit before we get
All right, so we're doing review 4. Again, Java with Maven. Let's write a program. Again, I'm a sports fan. I don't know about you all, but I like sports. Mr. Williams can agree with me that GOAT James. So let's write
Yes,
a
sir.
program that randomly generates his point totals over an 82 game season. We'll
When he
also
plays.
randomly go ahead. What'd you say?
I said when he plays.
He's playing real good now, playing more than KD. So we will also write in our program to randomly generate KD's point totals for 82 games. At the end of the season, we'll see who has the highest average scoring margin. We could also do this for rebounds and assists. Okay. If we wanted to do turnovers, I can include Russell Westbrook in there as well. All right.
Burn.
So new Java main class app. All right. And if you would like me to do a different sport, by all means, let me know. I'm just a basketball fan. Okay. So we have 82 games, right? 82 games, and number of games equals 82. Although I know it's 82 games, it's always good to create a variable to hold that number. You never want to just throw these numbers out. That way, I can change it here and it will change it anywhere in my program that I have number of games. Okay. Let's create LeBron scoring array. Int LeBron scoring. Oh, messed up already. Int brace LeBron scoring equals new int number of games. Why did I make this an int array instead of a double array? Anybody tell me? Again, this class is to be more of a dialogue, more of a conversation. So if you have questions, make sure you ask them. Programming 1, I'm just giving you the basics. Programming 2, I really want you all to engage, ask me questions, because now you're actually learning how to program. So if you have questions, let me know. If I'm asking you all questions, hopefully you know the answer, or at least a guess. So again, why did I use an int array instead of a double array?
Because it's a whole number.
Right. You cannot score half a point in basketball. There's no reason to have doubles. You can't score 0.7 points in basketball. It's only whole numbers, 1, 2, or 3. Okay. Let's do KDs as well. Int KD scoring equals new int number of games. All right. So we have our 2 arrays. Let's also do int LeBron rebounding equals new int, also number of games. Int KD rebounding equals new int number of games. Int LeBron assists equals new int number of games. Int KD assists equals new int number of games. So you see why I created this variable up here, number of games equals 82. That way, if it's a lockout season and they only play 41 games, I can change it up here and don't have to worry about changing these individually down here. What I change up here affects all of these. Whereas if I had put this number here like this, well, if it's a lockout shortened season, I would have to change each one of these to 41, 41, 41, 41, 41. And since we're human, we're prone to making mistakes. And you noticed I didn't change that one to 41. All right. So you want to make your code portable, meaning it can be applicable or change it once and it changes it everywhere. All right. So creating that variable, now I just change it once up here, it changes it everywhere. Does that make sense?
Yeah, that makes sense. That makes, like, keep it consistent.
Right. All right. So we want to randomly generate these scores. So we need a random number generator equals new random. All right. Control-Shift-I to import random. All right. Let's create some methods. Public static int points. And I'm going to take in 2 parameters for this method. And what I want this method to do is you pass in the minimum and maximum, and then it generates a random number, and it sends it back to the main, right? It sends it the however many points the player scored back to your main. Int min, int max. All right. Generate random number between min and max. Return the random number. Same thing, public static int rebounds, int min, int max. Same thing. Generate random number between min and max. Return the random number. Now, granted, you all at this point should be able to write these methods on your own. All right. So yeah, I'm going to show you how to do it, but going forward, starting next week, you should be able to write all of these methods on your own. If not, I'm happy to work with you to get you there. But don't wait till the last minute. Send me an email if you don't feel like asking in class. So I'm actually going to move this. I'm just going to create a random number generator in these methods. All right, so I can use it in those methods. So let's generate some random numbers in here. So int points scored equals random dot next int. Our bound, which is the parameter in here, is our range again. So our range is max minus min. And then we want it to go in between that minimum and maximum. So we have to add in the minimum because let's say, for example, the minimum points that LeBron will score is 20. The maximum is 40. All right. So 40 is the max, 20 is the minimum. What is our range? What is our range? If the max is 40, the minimum is 20. What was that?
20 to 40.
I couldn't hear you. What'd you say?
20 or 40.
20 to 40. But what's the range in between those two numbers?
20.
20, correct. 20. And so this random number generator, let's say max is 40, minimum is 20. So we're saying random.nextInt, and we're actually passing in a 20 because max minus min. So it's going to generate a number between 0 and whatever we put in here. So 0 and 20. But again, we want the number to be between 20 and 40. So we add in that minimum value. That puts it between 20 and 40. Does that make sense, or would you rather I actually go through that? Do I need to whiteboard it?
Just repeat what you said one more time, because it makes sense. I don't think you need a whiteboard.
So the random number generator generates a number between 0 and whatever we pass in these parentheses. All right. And we want to pass in our range. So if the max is 40, the minimum is 20, our range is 20. All right. So we're actually passing in a 20 right here. It's going to evaluate this, pass in the result. So we're going to generate a number between 0 and 20. However, we want the final outcome, the point scored, to be between 20 and 40. So let's say it generates a 17. Right, that's between 0 and 20. 17 plus our minimum gets it between our two numbers. So 17 plus 20 then is 37. That's between 20 and 40. All right, and I guess I could do a different range. Let's say our minimum is 30 and our max is 40. Our range is 10 now. All right. So this random number generator is going to generate a number between 0 and 10. Let's say it generates a 5. So we get 5 plus 30 makes it 35. That's in between our two numbers. So that's what I'm doing here. That's why I add the minimum back into this result. And then we return points scored. Right, so when we call this method, we want to return that value. So whoever's calling it, we return it back to that calling method. These other two methods will look exactly the same for the most part. The difference is instead of points scored, we're going to do rebounds collected. Assists dished. All right, so now we have our three methods. Granted, in the future, our methods would be a lot more complex and unique. Obviously, these all do pretty much the same exact thing, but I want to give you when you would have multiple methods and why, right? So let's do LeBron's stats first and then KD's. So let's loop through our arrays. And for each game, we're going to generate a random number for points, a random number for assists, and a random number for rebounds. So LeBron games. For int I equals 0. We want to start at 0. Every array starts at 0. I is less than, what should I be less than? How many times do we want to loop through this?
Is it
41.
No, it actually is 41. Yeah. 41, right? We could type 41 here, but do we want to type 41 here? What do we want to type here instead? Do we have a variable for that? Do we have a variable?
games?
Yeah, number of games. I plus plus. Okay. I equals 0. I is less than number of games. I plus plus. Again, I plus plus adds 1 to I each time we loop through this. We can also do this. Each array has a unique length value as well. We can also do LeBron scoring dot length. That'll just get us the length of our array, whether we know it or not. Java knows it. For this program specifically, we already know we have a variable that holds that size. So 80, number of games is 82. We put number of games here. If I do LeBron scoring dot length, that'll equal 82 as well. Right? Since the size of our array is number of games, it's all the same. So whichever one you use, it doesn't matter in this program. Oftentimes, however, you're going to want to do, if you're looping through an array, you want to use its dot length just to be safe. All right, so I'm going to keep that there. All right, so we want to generate a random number for LeBron, the points, the rebounds, and the assists. So LeBron scoring to index an array, meaning to get the slot in an array, we do brace and then whatever number we're trying to get. So if you want to get the first index in an array, what number should I put here? What is the first index in an array?
0.
Correct.
Zero.
Correct. 0. That's the first index. What about the last index? What number is that?
10.
Not quite. What's the full length of our array is what?
Uh,
What is the full length of our array? How many games are there?
82.
82.
Oh, 82.
So the final index in any array is its size minus 1. So with that, what is the final index of this array? The length minus 1.
81.
81.
81.
Correct.
Yeah.
So 81 is the final index in this array. However, we don't want to put those explicit numbers. Again, we have variables for that, and variables will keep track of that. Our variable that we're looping through with is I. I starts at 0 and goes all the way up to our length minus 1. So LeBron scoring at index I equals, I want to call our points method, passing in the minimum and maximum value. So what is the minimum and maximum value for LeBron in any given game? Anybody? I'll do 20 and 40, I guess. All right. Same thing for his rebounding. LeBron rebounding at index I, so starting at the 0 and going all the way up, equals rebounds, which is our other method. I'm going to say between 5 and 15. LeBron assists at index I equals assists. I'll say between 5 and 15 as well. All right, so each index in our array, we're going to loop through each index and we're going to randomly generate a point, a rebounds, and an assist. Let's do KD games. KD games are going to be the exact same for the most part. So what I can do is copy and paste this down here. Instead of LeBron scoring, it'll be KD. Instead of LeBron rebounding, KD. LeBron assists, KD. And I'm going to do KD scoring here as well. All right. So now each one of them will have points. And KD, I'm going to do between 25 and 50. Rebounds, I'll do between 5 and 10. And assists, 5 and 10 as well. All right. Cool. Now each player will have their points, rebounds, and assists for each game in the entire NBA season. We have 82 games. Each array is size 82. So LeBron scoring is going to be between 20 and 40 per game. His rebounds between 5 and 15. His assists between 5 and 15. So on and so forth. Just so that we can see that, I'm going to print out these array. So public, static, void, print array. And it's going to take any integer array. I'm just going to call it numbers. In our methods, whatever we pass in, the parameter now assumes that name. Arrays are passed by reference, and I'll go over that next time. Passed by reference basically is the original data structure or whatever. So in this scenario, we have an array. When you pass it to a method, that method parameter becomes an alias for that array. So if you modify the array in the method, it modifies the original array in the calling method. All right. So we have LeBron scoring up here. If I pass LeBron scoring down to the print array method, it's now an alias called numbers. If I say numbers at index 0 equals 15, LeBron scoring at index 0 will also equal 15 at that point as well. So again, arrays are passed by reference, meaning if you modify the alias, you modify the original data structure. The example I give, right? So I was a fan of Ghost, the TV show. Not Ghost, Power, sorry. It's been a while. All right. Mr. James St. Patrick, right? His alias was Ghost. So when Ghost hit the streets, if Ghost got shot, James St. Patrick got shot too. All right. So if you modify the alias, the original gets affected as well. Okay. Versus passed by value. Passed by value is for simple data structures like integers, doubles, and strings. Passed by value, it just passes a copy. So if you modify the copy, it doesn't affect the original. So let's say James St. Patrick makes a duplicate of himself. He clones himself, and that clone is called Ghost. But when Ghost hit the streets, he gets shot. James St. Patrick doesn't get shot. Okay. So that's the difference between pass by value and pass by reference. Okay. And please keep your cameras on at all times. All right. So this print array method, all I want to do is loop through whatever this array is, print out the values. So we need a loop for int I equals 0. I is less than numbers dot length I plus plus. You notice down here in this array, we don't have a variable that keeps track of the size of our array. But we do have numbers dot length, which regardless of the size of this array, is going to work. System.out.println or print. I'm going to print out numbers at index I plus a space. And then once we're done with this, system.out.println. So again, system.out.print prints it all on the same line. I do the system.out.println to reset the cursor on the next line. It's like hitting an enter. All right. So we have print the array. Any questions about printing this array to the console? What this method is doing? Thumbs up if you're good. All right. All right. So the next one is I'm going to compute the average of our array because we want to know how many points per game they scored, assists per game, and rebounds per game. Public, static, double, right? Because it's an average. Average is going to be a double. Compute average. Passing in this int array again. To compute the average, first we have to sum up all our numbers. So I'm going to create a variable sum to hold that total. We're going to loop through this array again. And each time we loop this through this array, we want to add it to our sum, numbers at index I. All right, so we're summing up all the numbers. Then double average equals sum divided by numbers dot length. That's how many numbers there are. And we just return our average. Everybody good so far? Thumbs up, thumbs sideways, thumbs down.
Good.
All right. Again, starting next week, and we will be in the classroom on Monday, I do expect you all, if I gave you this program, to be able to replicate it from scratch. So make sure you are cool with what we're covering. So now we have all these methods. Let's use them. Let's call them. So let's do system.out.println. Wrote James. All right. Let's print out his points per game, his rebounds per game, assists per game. So we have a method that prints out an array. So call our method print array, pass in the LeBron scoring. Print array, pass in LeBron rebounding. Print array, pass in LeBron assists. Right? Since that method takes in an integer array, it doesn't matter what these are called as long as they are also integer arrays. Right? The data type has to match. The name is irrelevant when you pass it to another method. System.out.print. I'm just putting a space. Let's do the same thing for KD. System.out.println. Slim Reaper. Print array. KD scoring. Print array. KD rebounding. Print array. KD assists. All right. So when I run this program, I expect it to be a long list of numbers with all their points, rebounds, and assists. Okay. And there you go. This is LeBron's games. These are KD's games, his points, his rebounds, his assists. Same thing for KD. See, we haven't computed the average yet. So let's do that. So instead of printing the array, which is a lot of gibberish, a lot of numbers, let's just print out his points per game, his rebounds per game, and his assists per game. So system.out.println points per game plus compute average, LeBron scoring. So I'm calling my method, passing in LeBron scoring array. Whatever number is returned, I'm printing that out. Let's do it for his rebounds. Same thing, compute average. And now you're starting to see why making methods are so beneficial. If I didn't have this compute average method, I'd have to write that code over and over and over again for each individual array. Instead, I can just call the method over and over again. System.out.println assists per game. Plus compute average, LeBron assists. Let's do the same thing for KD, and that'll be it for today. So instead of LeBron scoring, we're just going to pass in our KD scoring array, our KD rebounding array, and our KD assists array. Before I hit run, is everybody good? Kind of, sort of.
I gotta clean up some things, but I'll just ask you after class.
All right, before we print out the full array, this time we're just going to print out points per game and all that stuff. Let's see who wins the scoring title. So KD is gonna win the scoring title. LeBron got more rebounds and more assists per game. Still dropping 30 though. Year 19. It's amazing. All right. So you see, when we do stats, they're just running a program. Right? You go to ESPN and look at somebody's stats, they're just running a program that somebody out there wrote. Why can't it be you? All right. Well, that's it for today. If you have any questions about this, again, please ask me. I'm going to upload this to YouTube, maybe, hopefully today, quite possibly. No later than tomorrow, though. All right. Well, I'll see you on Friday.
Hey, professor,
sir. Have a good
professor.
Yep.
I need some help with something.